In a previous video, we've considered a fluid flowing through a pipe with a constriction. We've learned that in the region where the pipe is wider, the fluid flows slower. And in the region where the pipe is narrower, the fluid flows faster. In this video, we want to consider how this affects the pressure. If we have a region where the fluid is flowing slower and a region where the fluid is flowing faster, then in which region is the pressure greater? Is the pressure greater here where the fluid is slower? Or is the pressure greater here where the fluid is faster? We're going to do an experiment to try to answer this question. I have here two metal spheres, and the metal spheres are supported by these thin wires. And what I'm going to do is I'm going to take an air hose, and with the air hose, I'm going to blow air between the metal spheres. Now, if that moving air has greater pressure than the still air on the outside, then that greater pressure between the spheres is going to push the spheres apart. On the other hand, if the moving air has lower pressure than the still air on the outside, then the greater pressure in the still air is going to push the spheres together. So let's do the experiment. So here's the air hose, and you can see that it works. So now I'm going to have the air hose blow air in the space between the spheres. We'll see what happens. Okay, so we saw that when I blew air between the spheres came together. That tells us that the moving air between the spheres had lower pressure than the still air outside the spheres. So let's come back to the original question. Where is the pressure greater? If you have a fluid where the speed of the fluid changes, then we have greater pressure where the fluid is moving slower and lower pressure where the fluid is moving faster. So to sum up, when the speed of a fluid increases, the pressure in the fluid decreases. In the next couple of videos, I'm going to show you some more demos which illustrate this same principle.